Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Asmi'i bin Aznam, and the other two group member is Iman Hakim bin Mahyudin and Aizal bin Abu Bakar. Our lecturer for DMC 20013 digital system is Madam Siti Nur Azizah binti Mansur. So, in this video, our group will present about digital dice game. Let's go.
In our project, we have 4 main objectives. The first one is to understand how counter works. Second one is to observe the difference between asynchronous and synchronous counter. Third is to build the counter circuit using Proteus software. And the last one is to understand the use of counter in electronic circuit. Next, we go to the introduction of counters. Counters is a sequential circuit that can count the number of clock pulses it receives as an input. Counters are used not only for counting but also for measuring frequency and time increment memory addresses. Counter is created by arranging a collection of flip-flop in a specific order. A flip-flop can have 2 states, thus there will be 2 end state for n flip-flop, which is allowing us to count from 1 to 2. There are 2 types of counter, which is synchronous and asynchronous counter. Firstly, let's go to synchronous counter. Synchronous generally refers to something which is coordinated with other based on time. Synchronous signal occur at same clock rate and all the clock follow the same reference clock. In synchronous counter, the clock input across all the flip-flop use the same resource and create the same clock signal at the same time. So, a counter which is using the same clock signal from the same source at the same time is called synchronous counter. Next, we go to the second type of counter, which is asynchronous counter. Asynchronous counter are those counter which do not operate on simultaneous clocking. In asynchronous counter, only the first flip-flop is externally clocked using the clock pulse, while the clock input for the successive flip-flop will be the output from a previous flip-flop. This means that a single clock pulse does not drive all of the flip-flop in the counter's configuration. The required numbers of logic gates to design an asynchronous counters is very less.
Hello, Assalamualaikum. In my part, I will explain about methodology. This digital dice game circuit was created by using Proteus A. This software the simulation for the real circuit to look exactly like the real one. Okay, to complete this project, we need 9 components. First, we need 2 resistors that are value 150 kilo ohm. Second, we need 555 timer IC. Third, we need 14017 IC. Fourth, we need 14511 IC. And fifth, we need capacitors. We need 2 capacitors. One of the capacitor that value 560 picofarad, and the other one is 0.1 microfarad. 6, we need 9 diode. Value of the diode is IN4148. We need 9 diode. And 7, we need 1 push button. We also need 1 7 segment display, communicator. And the last one, we need battery 9 volt. Okay, next I will explain about 555 timer IC. Stable mode works as a oscillator circuit in which output oscillate at a particular frequency and generate pulses in rectangular wave. Using 555 timer IC, we can generate precise time duration of high and low output. Okay, we look to the diagram of the circuit diagram 555 timer IC. Pin 1 is the ground. Pin 2 is the trigger pin. Pin 3 is out. The pin 3 we connect to the push button. Pin 4 is a reset pin. Pin 5 is control pin. Pin 6 is a threshold pin. Pin 7 is a discharge pin. And the last pin is pin 8. This pin we connect to the VCC. Okay. To get time high, time low, time period, frequency and duty cycle, we can use the formula given. Okay, for the next component I will explain about 4017 IC. 4017 IC is a CMOS decade counter. It can successively provide output at the 10 pins, which is Q0 until Q9. The clock pulse at pin 14 is used to regulate this output. Q0, which is pin 3, output is high at first, then output advance to the next pin, which is clock pulse. Okay, we look for the circuit diagram of the 4017 IC. Pin 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, and 11 is output. Pin 8 is ground. Pin 16 is VCC. Pin 15 is reset. Pin 14 is clock. Pin 13 is enable. Pin 12 is carry out. Okay, for the last component at my part, I will explain about 4511 IC. This IC is used for available to drive the 7-segment display. There are many ICs that can be available to drive the 7-segment display like 4016 IC, 4033 IC, 4511 IC and more. Okay, for the 4511 IC, we look for the circuit diagram. For the first input is input A at pin 7. For the input B is pin 1. Input C is pin 2. Input D is pin C. For pin 3 is display test. Pin 4 is blank input. And pin 5 is store. Pin 8 for ground and pin 16 for voltage supply. Pin 9 until pin 15 is output. We used to connect it to the 7-segment display. Okay, that's all from my part. Thank you.
We go to my part, which is I will explain the result. In this circuit, we are using main component for the project, which is this circuit. We use 555 timer IC, 4017 IC, 4511 IC. This component really important to function this circuit. The result is every time we press the toggle, the 7-segment display will show a random number, like in the video. For the discussion, in this project, we have successfully simulate a digital dice game. This project was made based on the digital counter. Then we started by simulating this circuit in Pro Tools 8 and boot it from YouTube. To apply the clock plus at pin 14 of 4017 IC, we have to use a 555 timer IC in stable mode. The oscillated output generated at pin 3 of 555 has been applied to the pin 14 of 4017, so that output can be advanced with each clock plus. We can control the speed of 7-segment display by using potentiometer RV1. The rotation potentiometer can be changed the frequency of 555 timer, hence the rate of clock plus. After that, we use IC 4511 to supply to 7-segment display. The design of the product, we create a digital dice game that similar to the circuit. To operate this circuit, we need to press the button to get a random number from the 7-segment display. Now let's go to the conclusion. The conclusion is we can utilize the technology to replace the dice game that we are playing in our daily life. We complete this project by creating a circuit that can function as a dice game, where a complex circuit such as the one used in this project may show random numbers like a dice game. Complex digital logic circuits with millions of gates may be implemented on a single integrated circuit known as a microprocessor and can do millions of operations per second. We may use this to create more circuits like stopwatch, roulette wheels, and so on. So when we get in this project, we can use the IC and combine into a circuit to build a gadget like stopwatch or so on to use in our daily life. That's all from us, and thank you. Bye bye. Assalamualaikum.